Hello everyone, my name is Paul James and I'm here to present my project to you entitled Uganda Computer Graphics-Based Diagnostic and Skincare Simulation Platform. Before I dive further into it, let me first take you through the abstract so that we can all see the overview of what this project is all about. First of all, uh, let me yes, we understand that Uganda faces a severe dermatology crisis with only 25 specialists. It is already said actually from 20 to 25, which means we don't know the exact number, but that is the range, serving 45 million people. Well, this shortage has actually led to widespread misinformation that is being given by influencers on social media platforms. And this lead actually to harmful skin care practices in real life. Well, uh, my project, on the other hand, is going to address this gap, let me say, through an AI-powered platform that combines accurate diagnostics with educational simulations using tools like visual transformers, GANs, 3D graphics, and we shall also deliver a mobile accessible solution that achieves at least 80% diagnostic accuracy while supporting the UN Sustainable Development Goals. That is goal 3, dealing with good health, and goal 5, with gender equality. Well, that is my project overview. We can go further to my problem statement. Well, my problem statement is divided into domain, application domain, and then computational. On the application, healthcare, we all understand that healthcare inequalities persist in dermatological care due to extreme specialist shortages and biased AI systems. We don't say that these systems are not there. They are there, but they are biased. Why? Because they are being trained on the white skins, not on the black skins, African skins, Ugandan skins. And because of this, they actually tend to violate the SDG 3 and SDG 10, which of good health and then reduce inequalities. Thereby, they violate these things in a way that they exclude African population from quality digital health care because when when their systems are tested on Africans, they usually give incorrect data. So this is the reason why uh, that is among our problem statement. Another one is computational problem. Now, developing real-time skin condition simulations for diverse pigmentation requires integrating diagnostic AI with 3D graphics pipelines while maintaining mobile compatibility for low resource settings. And as we understand that the current solution failed to address these technical challenges, that is the reason why we are trying to develop this in place. Uh, we can go further to our objectives. In our objectives, we are going to create a tool. We are going to develop a vision transformer model to achieve 80% accuracy for Uganda skin conditions. And when we talk of Uganda, we represent Africa as large. That means Kenya, Tanzania, they can also be using the same system. We are also going to create a photorealistic simulation pipeline using the GANs and then Blender. And alongside that, we shall also build an interactive web platform with 3D avatar guidance in multiple languages. Here, the languages we are going to use Luganda and English. Luganda for localization and English for the rest of the work to be done. And for every other tribes to understand. For those who don't understand Luganda, but we measure in Luganda for now. And when we go ahead to our literature review, our research builds, of course, our research builds upon but addresses critical gaps in existing work. As I was saying, we are not going to be the first. There are already existing platforms in this, but we are going to put something that has been missing in the existing platform. For example, we are going to use generative models like Style GAN 3, Pixel 2, PhD, and enable realistic synthesis, like but lack African skin representation. Okay, this one is already there, that model. Now we are going to implement on that model. This model is already there. I can say it is based on white only, but not African. It is lacking. And then another one that actually prompted us among our literature review is segmentation architecture, which provides precise detection but suffer from training data bias. As we said, the training data bias is it is being trained on white, not on black skin and not on Ugandan skin. And then another one is we are going to use, let's look at the explainable AI part of it. And this increases transparency but remains unused in most dermatology applications. In most of the dermatology applications that are existing, explainable AI is less used. That is all I can say. And finally, we are going to localize our data set, which means our data set is mostly going to be Uganda skin care data based data sets. Yeah, which means especially, and this one is especially addresses the representation gap in the global data set, because global data set is always based on the white. Why? Africans have not sat down to include their kind here. And when we go to methodology approach, okay, when we go to methodology approach or pipeline, well, our pipeline integrates 5 key stages. That is data acquisition. We are going to acquire this data set with augmented samples from Uganda, and then AI processing. We are going to use visual transformers, classifications with the unit segmentation of our data set, and then we are going to simulate generation using Pixel 2 and Pixel HD. Texture synthesis for condition visualization. Yes, actually, it is a very good model, or it is a very good simulation. And then 3D integration. We are going to Blender avatars with 3D, I mean 3.js JavaScript library, real-time rendering. We are just going to render using that 3D. And then finally, we are going to deploy using React.js for front end and Flash for our back end for mobile accessibility. And then we go ahead and talk about our data set. When we talk about our data set, our primary source of data set is going to be from Uganda, and it is going to consist of over 5,000 images, annotated images, featuring Patrick scale ratings for skin tone, diversity, and then demographic metadata, that is age and gender. Sometimes also skins differ from gender. Some men's skin differ from women, and then age, it also differs at times. And then we are going to have like clinical diagnosis from dermatologists, if if possible, of which as per now I don't know one. I'm going to be honest, I don't know one, but we shall try that. And then another one is now, yeah, after that we are going to do pre-processing, that is standardizing our images by resolution 224 times 224 and or by 224. Now this one helps us to contrast normalization for consistency, of course, and then augmentation through rotation, flipping, and brightness adjustment. We shall deal with it from the data set, and when we are annotating also data set. And then finally, last but not least, we have model architecture and visualization. Now, when we talk of model architecture and visualization, we are going to talk of our input, our core AI, our graphics, and then our output. So when we talk of input, this one is just the user uploaded image reception. That is where the user is going to upload this image for visualization, and the AI core is going to be the VIT classifier and UNet segmenter and Grand Cam explainer. Okay, that is going to be on the AI part. Now, when we come to the graphics engine, Blender avatar, dredging, and Pixel 2, Pixel HD texture mapping will work. And then on our output, we are going to output the diagnostic report plus the 3D simulation plus the local languages or multi-languages. Multi-languages here, as already said, we are going to use two, that is Luganda and English. Those are the ones that we are going to use here. And let's evaluate our, let me evaluate the plan for this. Well, we have the quantitative, we have divided into quantitative metrics, and then user testings. When we go to quantitative metrics, we are going to achieve diagnostic accuracy of 80%. That is 80% to 85% at least. And then our simulation quantity is going to be zero point 0.8 for realism assessment, 0.85 or 0.80. And then our performance is going to be 5-second latency on mobile devices with 2 GB RAM, and it can even reduce like 3 seconds, 2 seconds if the RAM is higher, like 4, 8, and 16. Yeah, the speed at which this one loads is going to reduce. And then finally, user, we have user testing. Now we are going to measure diagnostic concordance. That is, first of all, evaluate the usability, and then we go to the field testing. We compare the rural versus the urban performance of this UI or of this system. And finally, allow me conclude by saying, societal, first of all, we have to deal with when I'm concluding, let me say, as I'm concluding, I will deal with the societal contribution first. Well, democratizes um, dermatological access through mobile technology. And then it reduces the harmful skincare practices from social media misinformation, and as well serves as educational tool for medical training and public awareness. And another one, other steps, okay, like the steps or the future, next step or the future improvement of our system. Now, the next step is we are hopefully we shall integrate our clinical, I mean, we shall integrate the clinical validation partnership with big hospitals like Mulago Hospital in Uganda, and also we shall put our app on Google Store, that is deployment part, and alongside that, we might also publish it in sites like Natural Digital Medicine. And then finally, we are going to expand beyond Uganda, like to other East African countries, South Sudan, Kenya, Tanzania, and so forth. Thank you. This is all I had to present.